So, guys, we are continuing on with graphs today, and what I want our focus to be on is understanding relationships. Now, I know this topic can sometimes be a little bit confusing, and it's sometimes like, what are we doing? What is all of this? And I want you to look at the bigger picture of everything because obviously we've named this series graphs, and yet you guys have not seen a graph as yet. On Tuesday, you guys did number patterns with teacher Coco, and now we're talking about relationships and where's the graphs. We're going to talk about how all of these things relate to each other today. And I hope that it makes sense and that, everything starts falling into place. Yes, Kia.
Ma'am,
Mm-hmm.
I would kindly like for us to go back to the topic of Tuesday because we really didn't do anything. There was a lot of chaos in the class.
Okay, I hear you, and we are continuing with it today. So there will still be number patterns in class today, Kia. So hopefully after today, you feel better about it, okay?
Okay, ma'am.
Okay, cool. So also, the other thing I wanted to tell you guys is we have covered number patterns earlier in the year. So on Tuesday's lesson, it was literally just a very quick recap. So obviously, if you were not with us when I covered number patterns, you would not have obviously known what was happening. So if you're still confused, Kia, go through the grade 8 playlist on YouTube and you'll see we've covered number patterns and we've covered functions and relationships before. Go through those videos and that will help you. Yes. So Tuesday's lesson was literally a recap of like 3 weeks of work that we did in previous terms. Um, so, anyways, today we're talking about relationships. And when we talk about a relationship, I want you to think of a mother daughter relationship or any family sort of relationship. And in a relationship, one person affects or influences the other. And that is basically the foundation of what a relationship is in maths. So in maths, we talk about a relationship where there are two variables that are affected by or that relate to one another. Okay. Now remember when we talk about variables, these are unknowns. And we call them we say that they're unknowns in this case because they're always changing. So for example, if you look at my example here, there's a relationship between age and height. So my two variables here are age and height. And obviously, my age constantly changes, as does my height. But what is the general relationship between age and height? As our age increases, what happens to our height? As our age increases, does our height increase or decrease? What do you guys think generally? Increase, right? So Uma is there. As our age increases, generally our height increases. So this is what a relationship is. There are two variables that affect one another. Either as one increases, so does the other one. Or sometimes as one increases, the other one will decrease. But what's important is that one will affect the other. Well, I know as you get older, you do tend to get shorter, but we're talking about, initially growing up. So this is what a relationship is. Now, it's a very quick explanation of what a relationship is, but I want you guys to let me know how are we feeling about the term relationships. Do we have any questions about a relationship um, thus far? Yes, that's cool. Maybe give me some reactions. I see Tandile and Liahua. Okay. Okay. So we're all happy with how a relationship works. There are two things in this relationship, one affects the other. Now, when we talk about these two variables, we can name these variables as input variables and output variables. Now, what I want you guys to know is there are many different names for this. So an input can also be called my independent variable. Independent variable. It can also be called my x value. Okay. My output is my dependent variable, and it is my y variable. Now I will explain what all of these means. What all of these mean in a minute. But what I want you to know is that the input is the same thing as my independent variable, and it's the same thing as my x variable. And so all that it means is my input is basically what you substitute into your rule to get the output. Okay? And the opposite applies for output. So my output is what you get when your input, or rather, let's say when the rule is applied to the input. So when your rule is applied to an input, you get an output. Okay? So I always say it's like a machine. Here's your machine. You put something in, whatever happens in the machine happens, and then you get something out. So we have an input. Whatever we put into our machine is our input, and whatever we get out is our output. Okay, so that is that. Now, when we talk about independent and dependent variables in our relationship, think of a mother and daughter. Do you think the mother is dependent on the daughter, or is the daughter dependent on the mother? What do you guys think?
Ma'am, you did a mistake on the output sentence. What you get, you wrote what get.
Thank you very much, Kia. Kia, while you're here, do you think you are dependent on your mom, or is your mom dependent on you?
I think I depend on my mom.
Right. So in a relationship, there's always one person or one thing that can stand on its own, that is independent, that can do stuff by itself. And so when we have that variable in maths, we call it our independent variable. And if we talk about age or height, do you think your height depends on your age, or does your age depend on your height? Which one makes more sense?
The height depends on the age.
Right. Your height depends on the age, which means that my height is my dependent and my age is independent, right? My age, it's going to go on regardless of anything. My age is going to increase regardless of my height, but my height will depend on my age. So obviously this is a very general example, and it doesn't always work that way with age and height, but it's just an example to show you guys how it works. So my dependent variable, I always tell my students to think of it as something that can stand or continue on its own. So my age is going to continue on its own, right? Regardless of anything. Um, my mom is going to continue regardless of what I do, right? But if my mom stops, what does my mom will? Okay, well, I suppose for you guys, if your mom stops cooking for you, are you guys gonna carry on? No, you're gonna starve to death. Okay, unless you learn to cook for yourself. But just for the example, that is what we're saying, okay? Whatever can stand on its own, whatever can literally be independent is our independent variable. Okay. And then when we talk about graphs, in the context of a graph, what you guys don't know as yet is that we draw graphs on our Cartesian plane. If you don't know what a Cartesian plane is, do not be alarmed. We are going through it next week. But when we draw a graph, we always put our independent variable on our x-axis. Okay, so that is why we call our input or our independent variable the x variable. Okay, and our output gets drawn on our y-axis. Okay, so if we were to go age would be here. Um, and I'm actually lying to you. Age was my independent, and my independent would go on my x, and my height would go here on my y axis. So that is why we call it x and y. Okay. So input value is what you substitute into your rule to get an output. We also know our input variable as an independent variable. Okay. And those independent variables are plotted on the x-axis. Okay, we draw it on the x-axis. Okay, our output is what you get when the rule is applied to an, look at what I'm saying, an output is what you get when the rule is applied to an, let me just write this whole thing again. So your output is what you get when the rule is applied to an input. Our output is dependent because obviously what we get out depends on what we put in, right? So our output is a dependent variable, and it is also going to be our y component over here. Any questions on this? Are we happy? Does this make sense? Again, not again if you didn't ever understand it, but does this all make sense? Are we seeing relationships? There are two variables. We can call them different things, but it's generally an input or an output. Or we can say independent and dependent, or we can say x and y. So I hope that all makes sense, and I am seeing your guys' answers in the chat. And I know some of us can cook, but I know some of you would starve to death without food being given to you. So okay, now that we know this, see, there's Liacho. Liacho is there. He's the one. Now that we know this, what I want you guys to see is that the same relationship between numbers can be represented in different ways. So when I say represented, I want you to think of, you know, in technology where you have like a cube or something, you have your cube, and then they ask you, show the top view, show the side view, um yeah. So all of these types of views, it's the same object, right? But you're just looking at it from a different perspective. You are showing it from a different angle. And so, in the same way, we can do that in math with relationships. We have one relationship, but we can show it in different ways. We can represent it in different ways. We can use words, so verbally, we can use words. We can use a table to show a relationship. We can use a flow diagram. We can use an equation, or we can use a graph. Are we all understanding this concept that we have one relationship, but we can show it using words, using a table, using a flow diagram, using an equation, using graphs? Does that make sense? Maybe give me some reactions, you guys.
Yes, ma'am.
Cool. Thank you, Liaho. Uma cooks. I don't know why I don't believe that. Okay, so now that we know this, I want us to look at one relationship, and we are going to look at representing it in different ways. Now, I know the series is about graphs, but it's going to be so difficult for you guys to understand graphs without understanding where our tables come from, how flow diagrams come into play, how number patterns come into play. So we are first doing our background work this week. So we're not going to look at how we use graphs today. What we will be doing today is we're going to go through tables, equations, and flow diagrams. And next week, we will start with actual graph work. because we have to do our background knowledge before we can start with actual graphs. So we have this problem over here. They say apples are sold at 16 Rand per kg. They want us now to represent the relationship using a table, an equation, and a flow diagram. So, first things first, I want to label the things in my table. So, usually, what we do is we have our input at the top and we have our output at the bottom. Whenever you're doing a table, this is what you want to do. In other words, my input is also my X, which is on top, and my output is my Y, which is at the bottom. Now, if apples are sold at 16 Rand per kilo, this is a relationship. Can somebody tell me what are the two variables in this relationship? What affect what? What are my two variables in this relationship?
Ma'am, I'm not sure. X and Y. If I'm sure, I'm not sure.
Okay, so X and Y, yes, but we have this sentence over here. Apples are sold at 16 Rand per kilogram. Can you explain to me this relationship like what we did up here, Kia? Remember up here we said that my age is independent and my height will depend on my age. So here, can you explain to me how does this relationship work between apples and its selling price? Okay, so I see you guys in the chat. So apples and per kg, the money depends on the apples. Yes, so that is 100%, right? So my apples, by the way, you guys, my apples and my kilograms are saying the same thing. My relationship here is between kilograms of apples and the amount of money I pay. So let us go back here, and I actually almost want to zoom in. So let me just erase this. So my kilograms of apples and the price I'm going to pay are my variables over here. So my input is going to be kilograms and my output is going to be price or total price. Okay. Now, why did I say this? Because I can take as many apples as I like. I can take as many bags. Let's say they come in 1 kilo bags. I can take as many bags as I want. And my price will depend on how many bags I took. So if I took one bag, guys, what is the total price I'm going to pay?
16 Rand.
Very well done. Yeah. Now, if I take 2 bags, what is the price I'm going to pay now?
32.
32. If I take 3 bags,
48, ma'am. 464. I don't know.
so it's 32 plus 16, 8 and 4, 48.
48.
What about 4 bags?
64.
I saw Valibi in the chat as well, 64. What about 5 bags?
80, ma'am.
Well done, Liaho. Now, I've used 1, 2, 3, 4, 5. What if I took 10 bags? What then?
160, ma'am.
160, ma'am.
Good job. So what I want you guys to see is when you are filling out a blank table. So when you have to create a blank table, a table from scratch, when you are filling out a blank table, you get to pick. You get to pick your inputs. Okay, so I get to pick 10. I didn't have to start with 1. I could have started with 27 if I wanted to. But remember, we want to pick our input strategically, okay? We want it to show a pattern. So here we can see I was plussing 16, plussing 16, plussing 16. Now that I've established I have a pattern, now I can go and pick random inputs that doesn't really, it's not really going to continue my pattern over there. So that is going to be 160. But obviously we know in between there was 6, 7, 8, 9, 10, which where my pattern was still continuing in between each of those. Then what if I took 25 bags? What then? What is my price then? Anybody?
Ma'am,
400.
400.
Good. Now, what if I extended this table? And what if I told you I paid 525 Rand? How many kilos of apples do you guys think I took? %. We take 525 and we divide it by 16.
Ma'am, the answer is 32,81.
I see. Obviously, we cannot buy 32,8 bags, but if they were just loose kilos, it
Then
means we
31,
bought, yes.
31, just 31.
So we'll go 32,8 kgs. Let's say we bought loose apples. Okay, we bought 32,8 kgs of apples. Okay, so what I want you guys to see is this over here is what you would have normally gotten if you were given a number pattern. You would have been given 16, 32, 48, 64, 80. Can you see how that's a number pattern? How we've now taken that number pattern, how we've put it into a table. Does this make sense? Kia, does this make you feel a little bit more comfortable with number patterns? I hope so. Great. And this is not the only example we're going to do. We're going to do more examples. Okay. So when you're given a number pattern, you can go, oh, and you can put it into a table like this. Now, when we're trying to find an equation, okay, what I want you guys to see is that with an equation, we need to now sort of figure out how do we get our output using the input. And what I want you guys to see is there's actually steps you can follow. And the steps is the first thing you're going to do is you are going to take your difference over here. So you're going to take your constant difference and you are going to multiply it with an input. Okay. So you are going to say 16 multiplied by, and let's use this input over here, multiplied by 4. Now, remember, I'm trying to get a rule. When my input is 4, what do I want my output to be? Anybody? When I have an input of 4, what is my output? Yes. So when I have an input of 4, I want my output to be 64. So right now, so far with finding my rule, I have 16 times 4. If we go and actually do that math, I immediately get 64. So here my rule is literally to take your term, to take your in. If you're using number patterns, you would go in. But since we're using X and Y notation over here, what we do is you literally take your input, which is X, you multiply it by 16, and then you get what your output is. And this is generally the format in which we want to write our equations. We want to write it as y is equals to, and then the rule y. Remember, when we're writing an equation, this y equals to really tells me, all that it tells me is it tells me how do I get my output by using my input. So to get my output I have to say 16 times my input, which is X. And this is my equation because it works. Now, you guys will see an example where it doesn't work and what you do then. But for now, this is how we find our equation. Uma, it is coming. Are we all happy with filling in the table and finding an equation on this example so far?
I'm happy,
Gloria
ma'am.
is with
I'm
me,
extremely
Uma is
happy.
with me, Liaho is with me, Lakeisha
Happy,
is with
ma'am.
me,
Hey, boo.
Demi is with me. Kia, do you have a question?
Yes. Ma'am,
Yes.
as I see in the chat, Uma is saying Tn is equal to 16n.
Mm-hmm.
Does the number have to have the n at the end?
No. So, and actually, Uma has just made me aware that there's another thing we can call our input. When we're using number patterns, we have term numbers and we have term values, okay? So when we talk about n is my term number, okay? So what he's saying is that instead of saying 16x, he said 16n instead. And when you're talking about a term number, you also have a term value. And your term value, we can write it as Tn. So it really is talking about my term when my input is in. Does that make sense?
Yes, ma'am, it does. Thank you.
So, and when we talk about a term, remember with number patterns, each term is just each number in my pattern. So over here, we're saying this number in my pattern is term number 4, and the value is 64. And so that is what Uma is saying. He's basically saying my output is equal to 16 times my input. N is just another way to write your input, and Tn is another way to write your output. Okay, now that we have our equation, we have y is equals to 16x. Can you guys tell me what is the rule I'm going to put into the middle of my flow diagram? Not 4. Not 4, Tando. Remember, 4 is one of our inputs. Times 16, 100%, Uma and Zach. Because remember, on my left-hand side, I have my input. On my right-hand side, I have my output. If I put in my input here of 4, in order for me to get my output, I have to multiply 4 by 16. And 4 times 16 will give us 64. When we had our input of 1, my output was 16. And we can see that it works. When my input is 1, if I take 1 and multiply by 16, it gives me 16, which matches what I want my output to be. When we have an input of 2, 2 times 16 is 32. 3 times 16 is 48. And let's use 25 as an input over there, and we get 400. Are we happy now that we have this one relationship? So let's look at it as a whole. We have this one relationship. We've represented it using a flow diagram. We have represented it using this equation, and we've represented it using a table. W is in the chat for sure. Okay, that's it. So I think we're in for a brain break. Yep. Again, not a long one. Sorry, guys. Did teacher Coco do the brain break with you guys?
Yes, ma'am, and we took time on it.
Okay, nice. The pillow faces. Oh, maybe I should take the hands first. But Zach, I see what you're saying. Gloria, yes.
Ma'am, on the desk, something's missing in one of the photos.
Let me
It's a
try and
book. It's a
see.
book.
Oh, that little squarey thingy, my Bobby. I see it. I see it. Okay, give me a
Actually, on
second.
both, on the desk and the bed stand thingy.
Okay.
The drawers.
Okay, so I see that. Thank you, Gloria. Okay, so I think I'm just gonna circle it on this one diagram because circling on both is confusing to me. So we have two. Thank you very much, Gloria. Who was next? Let me check. Zach, yes. What do you see?
Ma'am, it's like next to the window, like to the left, that cloud. It's missing on the second one.
Okay, next to the window to the left. Okay, I see the cloud. Yep. Anything else? You can give me another one.
And I don't know what that thing is on the windowsill, but it's like, it's on the windowsill, but it's like missing dots.
I see what you're saying. It kind of looks like a PlayStation to me. I don't know if that's just me. Oh my gosh, there's so many answers in the chat. Okay. Who is next? Liao, I think you were next, yes?
Ma'am, can you see the teddy bear that is sleeping, ma'am? You can see on the what you call this on the right picture, ma'am. You can see it smiling. On the other side, it's like covered itself.
Beautiful. Do you have another one?
Ma'am, I think on the right up somewhere up here. I can't really see,
Oh,
ma'am. I don't know what this square thing is over here, but it's like missing here.
square thing.
Yeah, ma'am. Go to the right, ma'am.
Like to the right picture.
Yes, ma'am. Yes, ma'am. Over there, where your mouse is.
Yes.
Yes,
Mm-hmm.
ma'am. Over there. That's the difference.
Oh, I see what you're saying, like the stop piece.
Yes, ma'am. I don't know what
Okay.
is that.
Yeah, and me neither.
Yeah.
Okay, so let me just count this quickly. We have 1, 2, 3, 4, 5, 6. Thank you very much, Leah. Ho. That means I can take.
Thanks, ma'am.
I'll take. I see 1, 2, 3 hands. On 3 new hands are up. Okay, I'll take the next 4 hands. So Unati, Uma, Shady, and Gloria, you're each gonna give me 1. Unati, what do you see?
Ma'am, you see where there's a picture of the cloud and like I don't know
Mm-hmm.
what those are, but
Like
like
over
if you
here.
look closely, yeah, but like if you look closely, there's like
Mm-hmm.
a gray mark, a dark gray mark, but then on the other side there is no gray mark.
Okay, I see what you're saying. I think it's like a little heart.
Yes.
Yes. Mm-hmm. Okay, so that was your one. Yes, I forgot we're doing one. Thank you very much, Unati. Also Gloria, I see Kia has a hand up. I know you've answered already, so I'm giving your spot to Kia. Sorry. Uma, yes.
Come here. Man, the hole in the cupboard, that bottom part of the cupboard.
Mm-hmm. I see what you're saying. Thank
Yes.
you, Uma.
All of them stole my answers, ma'am.
Don't worry, I didn't read the chat. If anybody in the chat said anything. But I Shady, you were next.
Ma'am, the light bulb.
Okay, hold on. So this was we're at 6, 7, 8. Now we're talking about a light bulb. Which light bulb?
Ma'am, the one on the left side has like something hanging the light bulb and the other one doesn't.
Oh, okay. I see what you're saying. Thank you very much.
No problem, ma'am.
Okay, so that was Shady. And then last one is Kia. Kia, do you see the last difference? Or did someone take what you wanted to say?
someone took what I wanted to say, ma'am.
Okay. Gloria, if you have it, you are welcome to answer now. Yeah, I see your hand, but ladies first. Sorry.
Okay, ma'am, it's fine.
Ma'am, please. Yes, Gloria. Gloria, you can answer. What's the last one? Oh, you don't. Okay, let me read. The thing on the windowsill, I did it. The light bulb, I did. The missing frame, I did. The heart is missing, I did. Ooh, what's the last difference? Are we all stuck? Let's see.
I think that's it, ma'am. I
I
can't
don't
find
even
anything.
have answers. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe it was 9 differences and I just forgot to change it.
Ma'am,
Mm-hmm.
the other picture is written printablesmania.com.
No. That does not count. I'm trying to even like look at the floorboards because I'm like, yo, maybe they're tricking us. I also don't see anything. Like, I'm even looking at the creases of the bedding, of the backboard. Yo, I'm also missing it, you guys. The mat. What about the mat? I also think the mat looks different. Like, it looks like it's at a different angle, but I don't know. Yes, Uma, what is it?
Ma'am, look at the corners of the pillow. They are different. One is further away, like slightly.
I'm not seeing it.
Ma'am, one pillow is closer to the headboard.
Let's see.
I mean, like, there's more distance between one and the other.
I don't think so. It looks pretty the same.
No, ma'am, like, put your head back and then just look at it, ma'am.
Uma, it looks
Ma'am, I
the
actually don't see anything, ma'am.
same.
Ma'am, I actually don't see anything over here.
Oh
I
my
think there's only 9
gosh.
differences, ma'am. I think there's only 9.
I think so,
Oh,
guys.
ma'am, there's
Anyway,
something that picture. There's something in the picture.
which picture?
That whole thing. I think there's a missing dot over there somewhere.
Oh, like this picture over here.
Yes.
Oh, goodness
Yeah,
gracious.
there's a missing. There might be a missing dot.
I
No,
don't
there's nothing.
see.
There's no missing dots.
It's okay, guys. That is it for our brain
I
break.
think there's just 9, ma'am.
Yeah, there's just 9.
What is it? There's no actually 10 differences. It's a
Yeah,
trick
what
question.
happens if that logo is blocking the 10th difference?
It's not. It's not, guys. I'm sorry. But I think it's 9. I'm actually going to go check because I do have the answers somewhere. I'll go check and I'll let you guys know. But back to maths for now. Yes, Kia?
Can we please go back to the example before the brain break?
Yes. Which example? Like up here?
Go back, go down, ma'am.
Mm-hmm.
Yes, ma'am. So, ma'am, I wanted to ask
Mm-hmm.
if we were to remove the last number on the
Flow
on the
diagram.
table.
On the
No,
table.
Yes, ma'am.
Yes.
If we were to remove the last number and we're asked to find the nth term,
Yes.
would we be all using the flow diagram or the equation?
So when they ask you to find the nth term, they're asking you to find the equation. And when we talk about the nth term, remember n is just another way to say my input, okay? So all they're asking you to do is find the term with an unknown input. So all they want you to do is find an equation, use variables. Ooh. So you're going to find an equation. When they ask you to find the nth term, you are going to use an equation. Okay, Kia?
Yes, ma'am.
And I'll show you guys now how to do that. I'm actually going to skip this one because what I want us to do is this. So we have this pattern over here. It says describe in words how this sequence is generated or made from term 1. So now we're describing a pattern in words. And so here what I see is we added 1 2 extra little circles, and over here we added 3 circles. So what did we do? From here we plus 2, from here we plus 3. So what I'm seeing is we are, and can anybody maybe tell me how to describe this before I give away the answer? We are adding consecutive numbers. Remember, when they ask you to describe a pattern in words, all you have to do is explain how do we get from one number or from one term to the next. Okay? So we are adding consecutive numbers. Okay? And we're not just adding any consecutive numbers, it's consecutive numbers starting with 2. Okay? So we added consecutive numbers starting with 2. So the question was, describe in words how the sequence is generated or made from term 1. So we added consecutive numbers starting with 2. And we're going to move along. Give me some reactions, you guys. Are we happy with how we describe these patterns in words? I think you would have done that on Tuesday as well.
Yes, ma'am.
Cool. Thank you. Now they're asking us to complete this table. Which goes on the top of my table? My input or output, you guys?
Input.
Input. Kia, is my input just my N or is it my TN?
It's TN, ma'am, I think.
It is just N. Okay. So remember, input is my number. It's my term number. So I know we say term number and then it makes you think TN is term number, but it's just your number. Okay. N is just for your number and your T is actually the value of your term. So there we go. And that means my output is at the bottom. Kia, what's the first input that I have over here?
1.
1. And what's my output when my input is 1? Okay, so let me help you, Kia. I know you said you wanted to revisit patterns. So when we have a pattern, all of the numbers basically that we've been given, and here we haven't been given numbers, but we've been given a diagram with a number of circles. So here, whenever you get like those numbers in your pattern, those are always our outputs. When you want to find the inputs for them, you literally just have to number them. So here, my input was 1. And what was my output here? How many circles do I have?
1.
1. Over here, my input is now 2. It's term number 2. How many circles do I have in term number 2?
3.
3. Beautiful. What's my next input?
3.
Beautiful, Kia. And last one, Kia, what is my output when my input is 3?
6, ma'am.
It is 6. So I'm going to complete the rest of the table and we're going to go 4, 5, we'll go 15, and we want N. So to go from here, remember we added 2. Over here, we added 3. Over here, we added 4. And actually, I'm not going to use N here because that is not going to work. I'm going to go plus 5. So this is going to be 10. This is going to be 15. Can somebody tell me how do I find my 15th term? Anybody have any idea? Itandile, yes?
Ma'am, you use TN, the TN method.
Right. But remember my TN method, so far we only know how to do it when there's a constant difference. Over here, we don't have a constant difference. So in this case, we would literally just have had to draw out our terms until we get to the 15th one. And I see actually, that's why I said I didn't want to do N because this was going to be a bad example. But what I do want you guys to see is when you are finding an equation and this doesn't work, let's say we said 16 multiplied by 4 and it gives me 64. But let's say in some other pattern, I wanted my output to be 70. What we would have had to do then is to make this become 70, we would have had to plus 6. So your equation here would have been y is equals to 16x plus 6. All that we do is we take our constant difference, you multiply it by your input, and then the third thing is you add or subtract whatever you need to get to the output that you want. So that is the concepts we went over today. I hope that we're all comfortable with finding equations, with using flow diagrams, with using tables, with patterns, how it all ties in, how we can have one relationship, multiple ways we can show it, all of the good stuff. If you have questions, now's the time to ask. If not, please go and do my quiz. And then enjoy the rest of your evening, guys.
Bye, ma'am. 100% is coming.
Liacho, you didn't get 100% last time. Just
Sorry,
by the
ma'am. I
way.
just missed one question, ma'am. It's just one question. Let's just call it full marks.
You promised me full marks, and when I went to look, I didn't see full marks.
Sorry, ma'am. Well, ma'am, it's better than nothing.
It is better than nothing. I was so proud. Thank you.
Thanks, ma'am.
Bye, guys.
Bye, ma'am. Bye, ma'am. Good night. Enjoy supper.
Bye. Thank
Bye.
you, you too.
Bye.
Bye.
Ma'am, I still have a question.
Yes, Kia, what's your question?
So, ma'am,
Mm-hmm.
let's say we were to use matchsticks instead of
Yes.
Can you kindly show?
I think I had one like that down here. Can we use this one, maybe?
Yeah, maybe it's came.
Okay.
And we're asked to describe the rule,
Mm-hmm.
draw the pattern, and find the nth term.
Mm-hmm.
So, ma'am, my
Mm-hmm.
question is, if it's like that, we're counting the matchsticks, ma'am.
Mm-hmm.
Why? Like you said, you can't find. We didn't use the nth term right now, ma'am.
Yes.
So, ma'am, why didn't you use the nth term? But if we had something like this, then we use nth.
Okay. What I want you to see here is, and I'll actually do this example with you. But what I want you to see is, do you see over here when I'm trying to see what we're adding each time? Do you see that each time my number gets bigger? It changes. My number changes.
Yes, ma'am.
We can only use the nth term method when we have what we call a constant difference. And a constant difference means that every time we try to find the difference between my terms, it gives me the same number. Can you see that over here, this does not work? Do I get the same number every time?
No.
No. So the nth method was not going to work over here. But let's look at how it would have worked here with this matchsticks one. Okay, we have this pattern below. How many sticks are in term 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And actually, we can even go input. We'll do a table right here. Input, and we have my output. Are you happy that my term number is my input here, and the number of matchsticks will be my output? Do you see that?
Yes, ma'am.
Oh, goodness. Sorry. Give me a second. I was trying to give Leah for the link and I did something. Let me paste that for you, Leah. Oh.
Thanks, ma'am. Sorry for the inconvenience. Thank you, ma'am.
Okay. So here you see my output is 12. In term 2, what is my output? How many matchsticks do I have now?
Bye, ma'am.
Bye, Leah.
Ma'am, I can't count properly.
Okay. What we know is this is going to be 10, right? This is going to be 10 because it's the same thing as the first one, except they took away these last two. Do you see that?
Yes, ma'am.
So we have 10 over here. Then they added 11, 12, and let me zoom in for you maybe. Then we have 11, 12, 13, 14, 15, 16, 17, 18, 19 over here. Do you see that?
Yes, ma'am.
Now, over here for this third one, we know that this, all of this over here is going to be 19 but minus 2. So we know this is 17. Do you see that?
Yes, ma'am.
Okay, so 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. With me there?
Yes, ma'am.
26. Now, what I want you to see here is to get from 12 to 19, what did we do?
We added, ma'am,
Added how much?
7.
7. To get from 19 to 26, what did we do?
We added 7.
We added 7. Can you see this is now a constant difference? I'm going to get the same number every single time when I try to find what's the difference between my terms. Do you see that?
Yes, ma'am.
And so they're asking us how many matchsticks will be in the fourth term. I know for the fourth term, all I have to do is plus 7 matchsticks. So how many matchsticks will be in the fourth term?
There will be 33.
It's not, yes, actually 33 matchsticks. Okay. Now, Kia, the next thing I want you to do is we're going to write down a rule. The first step when you're writing down a rule is you multiply your constant difference. And can you see now why it's not going to work when you don't have a constant difference?
Yes,
You're going to multiply your constant difference. Now, as you move up in your grades, they will teach you a formula. But for now in grade 8, we don't know the formula as yet. So this is the steps we're going to do. You're going to multiply your constant difference with your input. Okay?
Yes, ma'am.
And so far what I know is I know my constant difference is 7. And if I multiply it with my input, we can choose any input here. Which input do you want to use? 1, 2, or 3?
The second one, ma'am.
So let's multiply it with 2. When I get this, it's now going to give me 14, right? But
Yes.
when my term number is 2, how much do I actually want it to give me?
19.
19.
So we have to add the 3 and the no, ma'am. We have to add 7.
Not 7. How do you get from 14 to 19?
5.
Add the difference. And when I say difference, so I mean, okay, add something to get your desired output. So here, we're only getting 14 when we do step 1. I still have to add 5 to my answer to get my actual output. So what we have to do now is I've said, okay, my rule is now going to be my constant difference multiplied by my input. And remember, my input is n. And then I still have to plus 5. And this is going to give me my output, which we can write as Tn. Do you see that?
Yes, ma'am.
Can you see we've now gotten this nth term? When they ask you for the nth term, they're basically asking you to find this equation, which is Tn is equals to 7n plus 5. Do you see that?
Yes, ma'am.
Now, if you look at the next question at the bottom here, they're asking which term will have 110 matchsticks. So when I want to substitute, do I substitute 110 for Tn or for n?
Ma'am, n.
Not n. Remember, n is just my number. It's just the term number. Here they're asking me which term number, which means we don't know the term number. Remember, Tn is my output, and my output is how many matchsticks I have. So I'm going to I'm going to substitute 110 in for Tn. And that's going to give me 110 is equals to 7n plus 5. Are you with me there, Kia?
Yes, ma'am.
Now we just have to solve for n. I'm going to transpose my 5. It's going to become 110 minus 5, which gives us 105. You with me there?
Yes, ma'am.
Is equals to 7n. What do I have to do now to solve for n?
Yeah. Ma'am, don't you have to ma'am, can I please type something, then you correct me if I'm wrong?
Okay.
Okay. Ma'am, does it have to be something like this in order to find?
No. So we're here. Here we're doing equations. Remember, what's my goal with an equation?
We have to find the nth term.
So generally speaking, when we have an equation, we want to get my variable alone. Okay. So when you want to get your variable alone, over here 7n really means 7 multiplied by n. Do you see that?
Yes, ma'am.
So how do I get rid of multiplication? What's the opposite of multiplication?
Division.
It's division. So in order to remove my multiplication, I have to divide both sides. And Demi, you are 100% correct. We are dividing both sides. And here, what that does is the multiplication and the division cancel each other out over here. And because we are dealing with an equation, I can't just divide one side by 7. I have to divide both sides of my equation by 7. You with me there?
Yes, ma'am.
Now that we've divided both sides by 7, what is the answer you're getting?
And I'm trying to calculate. I don't know what's wrong with my calculator.
So you're going to put in 105 divided by 7.
Yes, ma'am. I don't know what's wrong with it.
Do you want me to give you the answer or do you want to try?
Ma'am, can I please try?
Okay.
Ma'am, I'm getting 15, if I'm right.
Beautiful. So on this side, 105 divided by 7 will give you 15. And 7n divided by 7 will just give us n. And so now, this is my answer. The 15th term, because remember, n is my term number. So term number 15 will have 110 matchsticks. You with me?
Yes, ma'am.
Okay. I hope this made sense here, and I hope that you understand now why I couldn't use this nth method for that other one. But what I will give you is, and this isn't going to work either, what I will give you is all of these. I want you to maybe, and actually that's not even going to work either. Okay. Yeah. So these you have done all of the rules with a constant difference. What I want you to do is I want you to go back and I want you to watch the videos on number patterns